Hi, you guys. My name is Miss Sechrist, and I am your biology teacher this trimester. For most of you, you had me last trimester. For the few of you who are new, welcome to Sechrist Biology. Today, I'm not able to be with you on Zoom, and so I'm going to walk you through our lesson here. You will also then go to Canvas and follow along the steps that I have posted on Canvas or those that are in the email. So today, you guys, we are going to talk specifically about a molecule, but actually we're going to talk even more narrow than that. We're going to talk about a specific element and a specific atom of that element. And the element we're going to talk about is the element that is super important to life. And it's often considered the element of life, and that is the element carbon. Last trimester, you guys, we talked about macromolecules, and we actually are going to go a little bit more in depth on looking at macromolecules and focus on biochemistry. So let's start by just talking about biochemistry before we really focus on carbon. And so as I'm writing, these are good things to put in your notes. If we talk about biochemistry, if I break that word apart, you see the word bio. Bio means life, and chemistry is the interaction of matter. And so we're talking about matter. And matter is anything that has space and has mass, or takes up space and has mass. And so what we're really talking about are elements. Now, if you guys think about elements, you might think about all of the different types of elements. Carbon is a specific element. And carbon is unique because of the properties that carbon has. And that's what makes carbon the element of life, because carbon has this ability to connect and bond and with other atoms in order to form these really large molecules that we know as macromolecules or biomolecules. And so as we talk about carbon, what is really important for you to understand is carbon as an atom. So when we think about an atom, so if I have an atom is the most basic form of a specific type of matter. So in this case, we're talking about carbon. One atom of carbon is going to have a nucleus in the middle. Okay, and so this would be the nucleus. And then inside the nucleus, it will actually have positives and it will have neutrals, okay? So a positive is known as a proton. These are subatomic particles. The neutral charge is going to be known as a neutron. And then floating around it, around the outside, are going to be negative charged particles, which are known as electrons. Now, we're not going to go into an in-depth understanding of chemistry, of atoms, how they specifically bond. But what you do have to understand is that these protons, these neutrons, these electrons, these are the things that allow atoms to behave the way that they can. These are the things that, and the number of these particular subatomic particles are what really allow elements to do the things that they can do. And so when we think about carbon, all right, the carbon, the atom or the element carbon is going to be an atom that has, if I go back to my diagram and I'm going to draw an atom of carbon, it is going to have 1, 2, 3, 4, 5, 6 protons. That's what makes it carbon. If it had 5, it would be nitrogen. It has 6 protons. The number of protons, its atomic number, determines what type of matter it is, what type of element it is. So in the nucleus of a carbon atom, it has 6 protons. In addition, there are also 6 neutrons. And so this is what's going to be inside the nucleus. All right? Now, around that nucleus are the electrons. And here's where it's super important. Because close to the nucleus, there are going to be 2 electrons, because that's all that fit. Think of a bookshelf that only holds 2 books. And then it starts filling extra bookshelves in. And so then in the next bookshelf, it's going to have 1, 2, 3, 4. Here's where it's super important. These 4 electrons only fill that shell halfway full. And these shells like to be full. Think about if you have books on a shelf and you only have half of the bookshelf full, those books are going to be more likely to fall over. Those books are going to be less stable. An element, an atom that does not have that outer shell full, it's going to be less stable. We would say that element is going to be reactive. It's going to react with something to form a molecule, but it's going to react with something in order to fill that shell, in order to fill its number of electrons. And here's the thing that you just have to kind of memorize is the number it wants to get to is 8. And so it needs 1, 2, 3, 4. These 4 spots are basically places, like a Lego block that allows it to hook to another Lego. These are spots that would allow it to bond with other molecules. And so when we're thinking about macromolecules, it's really nice. And why is carbon the element of life? Because it can connect with 1, 2, 3, 4 other elements. If it's carbon or if it's oxygen. So if you think about carbon dioxide, the carbon is going to get, there's 2 oxygen, the carbon's going to share 2 electrons with each of the 2 oxygen. That's why we have carbon dioxide. And you guys will understand that more as you move into chemistry. For those of you who are doubling up, you're probably getting some of that. But why we have to talk about this now, as we're moving into our biochemistry, is because the ability to bond with 4 different atoms is a great structural component that allows carbon to be the element of life and the building block that forms all these big molecules. Carbon is the basis of carbohydrates, those molecules that give you energy. Carbon is the basis of lipids, those molecules that provide insulation, that make up your cell membranes, that give you long-term energy storage. Carbon is the basis of protein. Proteins that provide structure, that provide the building blocks, that create the doer molecules, the enzymes. And carbon is the basis of your nucleic acids, which are your informational molecules. Why? What's so special about carbon? It will bond with 4 different molecules, 4 different atoms at one time. And because it can do that, it can create these large, wonderful structures that lead to the formation of life. So if we talk about carbon, the one thing we really want to understand is this idea of carbon bonding. Bonding is connecting 2 things together. So if I have one molecule here and another molecule here, the bond is how they are connected to each other. So all compounds can be classified as either organic or inorganic. When I put the word in front of it, it means not. So organic compounds are those compounds primarily made up of carbon. So our macromolecules were all organic compounds. Inorganic compounds do not contain carbon, with a few exceptions, and one of those exceptions, you guys, is carbon dioxide. Whoops. So carbon dioxide, you guys, that is not an organic compound. Now, it is necessary input to make organic compounds in the process of photosynthesis, but it is not an organic compound. The reason, as I said before, carbon has 4 electrons in that outer energy shell, and therefore it can bond with 4 other atoms. Carbon can form these chains, like in lipids. It can form branches, like in proteins, and it can form rings, like you see in carbohydrates. There are things known as functional groups. You do not have to know the names of these functional groups. These are just different types of molecules that are bonded together. And the reason that we talk about functional groups, or that I identify that in most organic compounds there are functional groups, is because these functional groups influence how they behave. For example, if you have a hydroxyl group on the end of a molecule, then when that molecule goes to bond with another molecule, all it has to do is get rid of the H with another H. And if it does that, it's going to release water. We'll talk about that in just a second. So you do not have to memorize the names of these functional groups, just that there are groups that we like to categorize as different groups: hydroxyl, carbonyl, amino, and so forth. Our focus here, though, is this idea of putting molecules, putting atoms together to form large macromolecules. Many carbon compounds are made up of smaller, simpler molecules known as monomers. Monomer is one. One is mono. Monomers can bond with each other to form polymers. So, for example, if I have 1, 2, 3 amino acids, because an amino acid is the monomer of protein, and I bond them together, 1, 2, now I have a larger molecule, which we would call a poly. Poly is many, polymer. The polymer is the bonding together of many small units, called monomers, into a larger unit. How are they formed and how are they broken is what's important today for you to walk away knowing. When we look at the formation, so when monomers link together, so when I have one monomer and another monomer, and I'm going to link it together, what happens is, take a look right here, is you have an OH, which is a hydroxyl group on one monomer, come really close to a hydrogen on another monomer. When that happens, the hydroxyl and the hydrogen come together and they pull away from their monomer. And if you look at this, if these two are going to bond together, what's going to happen is you're going to form H2O, that's water. And when those remove, what it's going to do is it's going to leave this open spot and this open spot. And if those two remove, they're going to be able to join together. And so when we remove water, so condensation means we're forming water. We just formed water, right? When we remove water, we actually are going to bond monomers together. Now, the inverse is also true. If we were to add water back, so if I have a polymer and it's bonded together and I eat it, now I want to break it down,